Deck lateral loads. Testing reveals answers. The publishing of the permitted lateral load anchor detail in the 2009 International Residential Code has drawn question to whether lag screws alone can support deck lateral loads at the ledger. Recent testing reveals that indeed they can. I'm Glenn Mathewson, former deck builder, master code professional, plans analyst for the City of Westminster, Colorado, technical advisor to the North American Deck and Railing Association, and ICC author and approved education provider. I'd like to tell you about recent research that reveals that lag-screwed ledgers handle significantly more lateral load than could be generated under worst-case loading conditions, all without hold-down anchors. But before diving into this, let's take a quick look at how lateral loads became in the 2009 IRC. You have to know the past to understand the present. At the first hearing in the 2007 code development process, the committee approved a proposed ledger connection table based on testing by Virginia Tech. But they expressed concern regarding the attachment of the band joist to the house framing. So a study was encouraged, but rather than a study, they got a detail for bypassing the band joist altogether for lateral loads. Now, 7 years later, a study has finally been completed, and the information we've learned can be included in the development of new lateral load provisions that are currently being proposed for the 2015 IRC. Researchers from Washington State University calculated wind and seismic lateral loads and tested live lateral loads and ultimate lateral resistance on sample decks. All research was based on a 12-foot by 12-foot deck. 4 articles revealing the research results were published in the summer of 2013 after the first code development hearings concluded. Wood Design Focus is a journal published by the Forest Products Society and is an excellent resource for wood engineering information from recognized researchers. In their wind study, they considered a 180 mile an hour wind in exposure C, a wind force present at the tip of Florida about every 700 years. Under these conditions, the ledger would only experience 650 pounds of lateral load at its ends. Under the more prevalent 115 mile an hour design load across most of the U.S., it would be approximately 266 pounds. The seismic study was based on soil class D, such as in California, and the lateral load at each end of the ledger would be only 259 pounds. Bear in mind that both these studies assume there are no other connections along the ledger, such as lag screws, that would be carrying some of the load. Something never before done, lateral live loads were tested with human subjects. A sample deck was loaded to 40 pounds per square foot with people swaying in unison. Perpendicular and angled decking conditions were tested, but no other means to brace the deck was provided. Loads parallel to the ledger provided the most force and displaced the deck by 7 inches. At this point, the researchers felt the deck inertia had overcome the force generated by the occupants, and a maximum live load had been reached. Under the worst case tested, and based on previous studies of bleacher seating, researchers determined 12 pounds per square foot as an acceptable and conservative lateral live load design value. For the 12 by 12 deck, this would yield 1,750 pounds total and 875 pounds at the end of the ledger, where hold-down anchors are permitted. The summary of worst-case lateral loading shows all sources are well below the 1,500-pound value in the IRC. But the question was whether the lag-screwed ledger and band joist could resist these loads. That's what this test answers. 2 12 by 12 decks connected to a mocked-up floor assembly built according to IRC standards were pulled laterally at the center of the joist span. Perpendicular decking was installed, and the test was stopped at 7,000 pounds. This was a comparative test. 2 identical decks were built and connected with lag screws. One was provided lateral load anchors, one was not. The decks were pulled to see how the ledger and band joist would perform. At 2,000 pounds of force, there was 3.5 inches of displacement. This is equivalent to the 7 inches of displacement measured here under the 1,750 pound force generated by the occupants in the previous test. At this load, significant joist splitting has occurred from the decking fasteners. But the test continued, and at 3,500 pounds, there was 17 inches of displacement at mid-span. At this point, the deck joists were well beyond failure. Testing still continued to a load of approximately 7,000 pounds, a force 4 times what could be generated by the occupants in the previous test. The lag screws never failed. According to the researchers, furthermore, even though the 2 outermost lag screws carried most of the force, these lag screws did not show any visible signs of withdrawal at the maximum load of approximately 7,000 pounds. This performance is reiterated in the article a second time. No visible signs of failure. But the real question is, how did the band joist handle the load? This is the concern that drove the IRC lateral load anchor detail. According to the test results, no damage was observed in the simulated house diaphragm. Further, the researchers concluded these results point to the effectiveness of 0.5-inch diameter lag screws when selected and installed per the IRC deck ledger connection provisions. NADRA represents the concerns of the decking industry and believes in safe decks with well thought out engineering and a common sense practical approach to code requirements. The lateral load provisions in the IRC have rocked the decking industry. Blanket values and specific details, now revealed as unnecessary, have no place in the IRC. The decking industry is asking for the results of this study to be well considered in the development of the 2015 IRC. Please share this video with those in the code and the decking industries. NADRA's code development proposals and public comments can be reviewed in entirety at nadra.org/code. For more information, concerns, or questions regarding deck codes, you are welcome to contact me. Thank you.